The purpose of this video is to introduce the work balance chart. So let's get started. When we think about Toyota Production System, we think of it as a three-sided organizational culture for people development. So we have a philosophical side, which includes the four key philosophies of the Toyota Production System, which are customer first, people are the key or most important resource, shop floor focus, and continuous improvement. We also have a managerial role, and the main managerial role is abnormality management. So manager's role is to always strive to make the abnormal visible and then to do problem solving to eliminate the abnormalities. And then the third side is the technical side. And over to represent the technical side, we have the TPS house. And this includes all of the tools of TPS. And there are actually many more tools than what some people realize. So this is a matrix explaining how the tools are broken down. We actually have four major categories: TPS basic thinking, just in time, improvement of productivity, and Jidoka. Then we have 22 classifications under those four major categories. And then we have 367 TPS tools and unique techniques that are used in different ways in different applications. They're all considered, TPS tools and or techniques. So that's the three-sided organization. So our focus today is on one of the TPS tools used extensively within Toyota to quickly grasp the condition of a process or line and develop a Kaizen strategy. It's the work balance chart, Yamazumi. So there's a video that we're going to show briefly that was created for a presentation at the Bluegrass Automotive Manufacturers Association. But I want you to watch this process briefly and see what you can observe about it, and then what should be done about it. You can see that this is process one. There's a counter here to count how many pieces are completed. And this timer is for changeover, which we're not going to watch changeover. You can see process one just completed a part, moved it over to process two. Process two punched some holes in it. It's doing a quality check. Is inserted it into a machine sleeve. Now process three picked up that part as it has it into the machine, and the machine's running. It's a 12-second machine completion time. And when it's finished, team member will remove it and take it out of the sleeve and place it into the SIPS location. Process four is now working on it, putting in some stickers. It's an OSU emblem, if anybody's interested. This is an OSU spirit card, and now that's completed. So it shows one cycle, of one part going all the way through. So what did you see? Did you see problems? Were you able to tell if there was something wrong? And then if you could find some problems, what should you do about the problems? And how are you going to do it? Then another question you might be asking is, well, what would Toyota do in a situation like this? So Toyota uses 3 sheets of standardized work for processes similar to this. The first one is a production capacity sheet. The production capacity sheet is to understand if equipment can meet customer demand or not. So normally when we go to look at a process, we might do this sheet very first, because a lot of the Kaizen activity that we do is motion Kaizen for the team member to try to reduce the non-value added or wasted motion team members might have. But there's no point in doing that if we have a situation where a machine cannot meet customer demand. We need to work on the machine first. So that's why we might do this one very first. But we also make a standardized work chart, which really shows the walk of the team member and where he walks to do each element and when he returns to start. And then the standardized work combination table which is really to visualize the relationship between the human and the machine. So those are the 3 sheets we normally use, but even before we make these sheets, there's another tool that we can use that's going to give us a very good grasp of what needs to be done quickly. So on our time measurement sheet, this is a standard time measurement sheet used at Toyota. At the very top of it, we have a place to capture 10 cycles. Down below in section 2, we can capture the work elements, and we can time each element and break down the overall cycle by element by element. But first, what we do is we quickly capture 10 cycles, and then we can create a work balance chart Yamazumi. So that's the topic that we wanted to really look into a little bit deeply today. Here's what a work balance chart Yamazumi looks like. So some of the key points, we've got the cycle time, which is the lowest normal time to complete the work, which you observed. So in these 10 cycles, you identify the lowest normal time, and that's what goes in this 52.8 seconds. Second part is the fluctuation range. And so fluctuation range would include cycles that were above the cycle time, but nothing abnormal really happened. And it was all variation from within the process. Nothing abnormal happened, such as a machine downtime, or the process had to wait for a previous process or the following process before they could complete their work. So this is just normal fluctuation within the process itself. And that's represented by a dashed line. And this is the highest normal cycle time that was observed. Then we have an average time, which is just the average of the 10 cycles, or if you only get 9 cycles, it could be 9 cycles, 9 normal cycles. And next we go over to what we call the calculated side of the work balance chart. This side is actually based off observation, but over here you might be doing some calculations. So we have the periodic work time per piece, and so if you can observe the periodic work and understand how frequently it has to be done. For instance, if you had to do 20 seconds of periodic work every 10 cycles, then you would say 20 seconds divided by 10 cycles equals 2 seconds per cycle. And so you would plot 2 seconds right here with a diagonal cross hatching to represent periodic work time per piece. And then there would be changeover time per piece. For instance, if you had a changeover that took 200 seconds and you had to do it every 100 pieces, then it would be the 200 seconds divided by 100 pieces, which would be your lot size, would be equal to 2 seconds, which you would plot here in this checkerboard pattern, the vertical and horizontal cross hatching. And then the average on the calculated side would just be this average plus the 2 seconds here and the 2 seconds here, so it would be just 4 seconds above what this one is in the example that I was talking about. And then finally we have the star, which is really the rate of the actual output. So those are the key points of the work balance chart. But the objective of the work balance chart, Yamazumi, is to quickly grasp and visualize the condition of the process versus takt time, to support target setting and developing strategies for Kaizen, and to visualize the condition so you can gather and persuade key people to support your activity. So it's a very important tool because of the clarity that it can give and the ability to use it to show people what you observed. I think that's also a key point. This is what you actually saw with your own eyes. So you're not based off some data that was captured in a computer. You actually saw it with your own eyes, and then it's almost like you're an eyewitness to the scene of a crime, and you can tell people, this is what I saw and this is what happened. And it's it's not something that's really going to be debatable. And then this is a work balance chart for those 4 processes of that video that we watched earlier. And so in this case, we have a takt time, which takt time is really the pace of sales. So for instance, if you have, let's say that you have a customer wants to buy parts from you, and the rate that they're buying the parts is 1 every 20 seconds of your normal work time. So that would be your takt time. I don't think we might go into how to calculate the takt time a little bit later, but for now, let's just continue on talking about the work balance chart. But I think the key point is this is the pace of actual sales. It's not the line speed, it's not the target cycle time, it's the pace of sales. So if we look at the process 1, we see that we have a 12-second cycle time. We've got 3 seconds of fluctuation, which is above our target. We have a 10% of cycle time is usually our target, so we should be trying to look at how can we get that down to where it's only about 1.2 seconds of fluctuation rather than 15 seconds of fluctuation. And you can see one of the TPS basic laws is to pursue full work. And ideally, if a team member has full work, or if a process has full work, then their normal cycle time should be equal to the takt time. That's ideal condition. So in this case, you can see we don't have full work. So that means basically that this team member is working for 12 seconds, and then because the takt time is 20 seconds, he's waiting for 8 seconds every cycle. And so this is a very poor condition for a process. The team member is being disrespected because we're saying, your time's not really that valuable to us. We're only going to give you 12 seconds of work out of every 20 seconds. So this is it's a form of disrespect to the team member, but it's also a huge form of waste. And then the star shows us that we're able to produce a part every 23.6 seconds. I think one of the key points for this work balance chart is because the way that the line that was designed, the way it was designed, there can't be any buildup of material between the processes. And so whatever the bottleneck process is able to produce at, everyone else, that's as fast as they can produce also. In some cases, you might be in a real world situation where the lines are not directly connected and some material can build up between each process. And then in that case, every process would have a different actual rate of output. But the bottleneck cycle time would still have this 23.6 seconds because he can't go any faster than that. That's what the observation showed of the cycles that I watched to create this work balance chart in Yamazumi. Okay, so then the other key points is we have some angry clouds on here. So process 1, 2, and 4 do not have full work, and cycle time is less than takt time for those 3 processes. Also, they all have high amount of fluctuation, greater than 10% of cycle time. And process 3 has a huge wait time. One thing I want to point out, which is a good learning point for us, if you look at this average time, it's the average of all these normal times, the 15-second lowest normal time and the 22-second highest normal time plus everything in between. Why is this average so skewed down here? And so I think this is a good learning point. Normally we would look at this and say, no, it should be about right here if you caught only normal times. But in this case, process 4 was new. The team member that was doing this process was very new to this process and was just learning it. And so the first 2 or 3 cycles were a little bit high, but I didn't throw those out when I did my calculations. So in reality, after the team member had done 3 or 4 cycles, it got much better and they had a much lower average for all the other cycles. So anyway, this is an example of how maybe I shouldn't have used those first few times that the team member did the work, because it's really not a normal time. This is a valuable tool that you can use to help understand what you should be looking for on a work balance chart, Yamazumi. So let's just go through one case. Case number one, let's ask ourselves two questions. The first question is, can we meet demand? If the answer is yes, okay, then the next question you ask yourself, can we do it? Are we using overtime to do it? And if you said yes, then that signifies that you are in case number one, and there's probably two possible phenomenons that you should be able to see in your work balance chart. One is that takt time is less than cycle time, and we're also working overtime. So in this case, if we look over here, phenomenon one is seen here. Here's takt time line. You can see that it is less than the cycle time. So that means in normal conditions, the team member is never going to be able to meet the required number of parts needed by the customer without working some overtime, because the cycle time is greater than the takt time. Phenomenon number two is actually cycle time is less than takt time, but OA is very low. And that's why we're working overtime. So if we look over here, we can see phenomenon number two is shown here. So we've got a cycle time, and it is less than the red line, which is the takt time. So that's true. And then our OA is way above the takt time line. So our actual rate of output, the star, is much higher than the rate required by the customer. And so based on these two phenomena that we see here, we have different points of Kaizen, some similar too. But in phenomenon number one, we should be trying to get our cycle time down below takt time. The fluctuation is still too high. The periodic work is having an impact on the actual rate of output. And because of our downtime, we're having too much, our rate of actual output is too high. So we can work on all these points of Kaizen to try to improve phenomenon number one. Likewise, in phenomenon number two, fluctuation should be worked on, periodic work and changeover time could be worked on. We can work on our downtime to improve our OA. But in this case, there's really no need to work on the cycle time. So, if we're in this situation, we don't need to work on reducing cycle time. So you can go through the rest of these on your own, but that's just, kind of an explanation of what you can look at and what you can learn from this. So this diagram was actually, I created it in Excel, but originally my Japanese vice president, he was at a Jishikan activity that I was leading, about a 15-minute lecture on the work balance chart. And this is what he drew up on a flip chart. And I took pictures of it at the time, and then I converted it to an Excel file so that we could use it for teaching purposes. Okay, here's another good chart that we use at Toyota to help understand conditions. So a lot of times, always when we're trying to do a Kaizen activity, we identify a gap that we want to improve. And so this shows you an example of many different gaps that you could potentially be working on. So we've got a gap, ideally the cycle time should be equal to takt time. So we've got this big gap in this initial condition, so we could be working on that one. Likewise, these other gaps, you have some idea of the different types of gaps and what they represent. And you have a target condition, which we should be trying to achieve. I think the key point on the target condition, the actual rate of output should equal the takt time. So that's what we want to try to always be trying to get to as our target right here. Now, ideally, what should happen is we should have a cycle time that is exactly equal to takt time, and our average time to complete is exactly at takt time, and our rate of actual output is exactly at takt time. That's ideal condition though. So I think this is another valuable chart. I hope you guys find some use in it, and maybe you can study it and understand it well, and maybe you can actually use it to teach others. Now I want to switch gears a little bit. I want to talk about type 3 work balance chart, Yamazumi examples. This is example of how to study a process that is not tied to a specific tack time. Maybe something, it could be related to some administrative work, or it could be, example, some types of work in healthcare would use this type of Yamazumi to study and understand where the potential improvement points are. So some of the key differences for this type of Yamazumi, we call it type 3 work balance chart Yamazumi. So instead of a tack timeline, we have the normal working time of the team member or the process. So in this case, this is minutes here, and the normal working time is 445 minutes. So after doing an observation and collecting data by observation, we identified what this fork truck driver did to do his work for the entire shift. And so we break it down into different categories: pin pallet management, CTR1 support, CTR2 support, blanking press, blanking truck, information gathering, changing the fork truck during work time, charge fork truck during work time, and then waiting, walk, and double handling. So that's an example of what that happened on that day. And there's many Kaizen points within here of how we could try to reduce that team member's time, especially the waste. Then another example of the Yamazumi chart, these are actually conveyance processes, and so it shows you the 4 different processes. So it's 4 different team members. They have a normal working time of 450 minutes per shift. And you can see that for each one, we go back to one of the TPS basic laws we talked about, pursue full work. We can see right now that the team members have a gap between their work plus their fluctuation that they're doing. There's a gap here. They don't have full work. None of the team members do. So the idea is, can we reduce the fluctuation and potentially do some Kaizen on their normal work so that we can maybe we can rebalance the work, potentially not reduce the number of people, but reduce the process and give one person some other value added work to do. So potentially, can we take some of this work and divide it over to these other 3 and eliminate this process, and then give the person that's actually doing the work now, give them some other value added work. So that's the way we would use a Yamazumi chart. So I could see where you could use this potentially in a healthcare situation. Maybe you have X number of administrative people who are greeting patients and filing and typing and that type of thing. Find out exactly what each person does in one normal day, and then understand how much waste there might be, and then try to figure out ways where you can do some Kaizen activity and some rebalance and be able to reduce a process. At Toyota, we don't reduce people, we reduce processes, because we want to be able to give people full work, but we don't lay people off. We keep the people and we give them other value added work. We might go from 4 processes down to 3, but then that just means one team member is freed up to go work someplace else and to do some value added work. Here's another example of a different fork truck Yamazumi and how some detailed information was gathered, 450 minutes of work time. And we gather the detailed information, but then we also take it and we break it down into 3 categories: value added, incidental, and muda. And these are general categories, but it helps us do a quick understanding of, we only have this much, 300, looks like maybe 310 minutes of incidental and value added work. The rest of that day is waste, it's muda. And so if we want to first attack the muda, well, let's go back and break it down into what was the muda again, and understand the muda more clearly. And it looks like, beginning condition was we had 142 minutes per shift. And after doing some Kaizen, we reduced the muda to 68 minutes per shift. So the next steps would be, let's Yokoten those Kaizens we did to the other fork truck processes in the area and try to reduce one fork truck process and give all the team members more full work, which is one of our TPS basic laws, but then also take the extra team member we have now and put them in another area doing some other value-added work. So really, that's the synopsis of all of our Yamazumi chart elements in the type 3 chart. And I also have just one more generalization about the work balance chart matrix of terms, something that you guys can potentially use to study and to prepare for to use this in the future, and maybe use it to help teach other people. And there might actually be some exam quizzes based on some of this information. So that concludes what I had to present. I hope you find it helpful, and let us know if you have any questions about anything. Thanks for your time.